on it. Okay. Let's see. I don't know if I'm in frame. Okay, welcome to the February Northwest C++ Users Group. Couple of announcements. First off is we did go ahead and kill the meetup group. Didn't seem to be helping us, and our sponsor kind of backed out. So we said, yeah, we're not going to do that anymore. If you get anything from meetup saying the group is dissolved, it is not. We're obviously still here. So just ignore that. Given nobody's panicked over the group being dissolved, I kind of goes to the fact nobody was paying attention to meetup. Not next month. So just a warning. Next month is kind of our normal Thursday meeting, right? Which is not normal because we moved from Wednesday to Thursday. After that, we're moving again. Not to Thursday. We're still going to stay on Thursday. But they're moving us a little bit earlier. So instead of starting at 7, we'll start at 6:30 and go to 8.
Oh.
So they're basically aligning us with all the other activities going on in the buildings. Hi, C++?
Yep.
Come on in. Let's see. So that's kind of my two announcements. Hey, I got one more announcement. Or actually, I've got two more announcements now that I think about it. I'm not done yet. Sometime this summer, probably August, we will skip our normal meeting and we're going to go do a pizza feed. We'll get like one of the picnic shelters at a park and we'll do a little social pizza feed thing. So keep it.
Pizza feed, is that what it sounds like?
We will
You're gonna feed us lots of pizza?
I'm going to, yeah, there will be pizza fed. So, yeah, we're kind of doing that in lieu of, bringing it in here all the time and it's, life's different now, so we'll adapt. The other one is later in the year also, we'll be doing a lightning round session. So if you got like a little 5 or 10 minute talk that you want to do, you don't want to do a full presentation, but you want to just do something quick and easy, get that ready. We'll probably do it like right before a CPP con or something like that. I'll see where it fits in. And if you want to, I've got like 2 or 3 slots for speakers left this year. If you want to speak, let me know. Otherwise, you're going to have to wait till next year. You're good till 2025.
Yeah, I'm good till next year.
That's what I've got. Hey, I see Chris online. Do you have anything you want to talk about for conferences, Chris?
No, just to notice that the call for submissions for C++ now has concluded. Actually, CPP North in Toronto is still open for another week and a half or so. So if anybody's looking to go to Toronto and wants to speak, other than that, that's it.
Okay. Any other announcements from anyone, any topic?
Just a quick question.
Yeah.
Nobody from VC++ group are attending?
I am.
You are? Awesome. Good to meet you.
I'm here in a semi-official capacity,
Are you
so
a program manager or?
I am a product manager or former engineer, but not on Visual C++.
Ah,
Other stuff. Used to work for Synop. Standing out.
cool. Welcome. Actually, you got a couple new people here. Actually, you're new too, aren't you? This is your first time?
No, I used to attend a long time ago.
Okay.
I used to work for VC++.
Ah,
Patrick.
okay. Well, welcome to the new people and the returning people from distant past. Anyway, with that.
That's me, ancient history.
Yeah, tell me about it. I'm in the same boat. With that, we'll turn it over to Walter to talk about crafting self-evident code with D.
All right. I guess.
Yep.
On the remote.
It pans.
But you,
There you go.
not only do you want me to run your slides for you, you want the camera too?
Yeah.
Oh, okay.
Don't wander around too much.
You don't get a lackey too often, so.
I see where I sit.
Okay, I've been coding a long time, okay, like really long time. And I've noticed a pattern. maybe you guys have noticed it too. If I look at code I wrote 5 years ago that I thought was great code, I look at it and I have no idea what it's doing. And the code I wrote 10 years ago was worse. And you see where this is going. Okay. Things are very different when you're writing the code and when you're looking at the code later. And if you think understanding your own code is bad, just imagine somebody else looking at your code. Okay. They're not going to be able to make heads or tails out of it. Next slide, please.
Hopefully by the time you found another job, they can't complain to you.
Yeah, that you see.
Sorry for the interruption.
Okay, a lot of people programming like to show how clever they are. Okay, after you've been beaten up so many times, the highest praise you can get for your code is, that's so simple, anybody could have written that. Then you nailed it. It turns out to be surprisingly hard to write code that's so simple anybody could do it. I mean, look at Einstein's equation, E equals mc squared. It's so simple anybody could have thought that. Yeah. In fact, I would have thought of that if I was.
If you were him. Right.
Absolutely, I would have thought of that. So next slide, please. Okay, if you've been around for a while, you start hearing all these things. They've even written books with these titles: secure code, safe code, clean code, modern code, structured code, optimized code. You've seen all these before. And they kind of go in and out of style over the years. You know, different ones get emphasized and all that. Well, we're not going to talk about any of that stuff. Next slide, please. Can you read and understand your own code? You notice that was missing in all these other slogans about writing good code. And can you read it and understand it? Well, that's what we're going to talk about. Next slide, please. Okay, this is code that I used to write.
Oh my gosh.
I wrote this code in the 1980s, and it's real code, and I won a prize for it.
Obfuscated C prize?
Yes, I won the obfuscated C code contest. You're not supposed to say that. This is supposed to be how. Anyhow, this is how most of my code I wrote in the 1980s looks. I didn't have to try hard to enter that contest and win it.
Was the price of obfuscated too?
The prize was I got my name written as I won.
Did you read your name after it was written?
Was it written?
I wrote it in my name in Elvish, and nobody's figured that out yet. Linear B. So anyhow, it doesn't matter what it does. Okay. Now, all you guys who know airplanes are disqualified, but you see that lever? What does that lever do? It's a lever you find in a cockpit.
Something with a chassis
Something with a chassis?
Does it lower the wheels?
and ailerons.
Why do you think it's about lowering the wheels?
Well, it kind of looks like a wheel.
You win the grand prize, okay? That's exactly what they do. That's so that the pilot knows by putting his hand on it, he's got his hand on the right lever. You know, you don't even need the label on what the thing does. When you move the handle up, the gear comes up. When you push the handle down, the gear goes down. And even if the cockpit is filled with smoke and you can't see anything in there, he can find that landing gear thing and lower the landing gear. Okay? This is the ideal we aspire to in programming. And there are other controls in the cockpit, like the flap levers have actual flaps on the top of them. Okay? And they try to design the controls this way. They fail sometimes. I was told by one of the people, actually the lead engineer on the cockpit design, that every obvious feature in the cockpit was paid for by blood.
Yeah.
Every last one of them. Because people only learn what's intuitive and what's obvious in hindsight, which again goes back to so simple anybody could do it. Well, even the best airplane designers.
That same rule holds in the rockets as well.
Yeah. So I've read a bunch about the Apollo rocket, and that was a fiendishly complicated cockpit. And I don't know how they didn't just hit all the wrong switches and blow up. But anyhow, that's off topic for now. On to the next slide. Has anybody ever seen this? Yeah. This was common in the 1980s when people migrated to C from Pascal and they thought, this macro system is so cool, I can make C look like Pascal. And it didn't take more than a couple of years before people realized that this is a really bad idea. But it is a bad idea that doesn't resurface in that form, but in other forms too. Next slide, please. How many people have seen this in their C++ code?
Not in mine, but in others.
Yeah, we say to decode all the time. I do not understand why this intense, and I mean intense desire to paper over a bool and call it something else. So you guys know the difference between the two lines. The first entry is defaults to 0 and the second to 1. So, you know, you really don't want 1 being yes and 0 being no. All it's going to do is you're going to push the wrong button and it's going to blow up. That's why, you know, I can fix the guy who did the first one. The second guy, he's just no higher.
And the scary thing is that's not the worst response I've gotten on interviews.
And why is the begin end thing a bad idea?
Because what you're doing is you're inventing your own language. Okay?
So,
It's no longer C, it's your own language. And I have a Microsoft story
sure.
about that. A long time ago, a Microsoft employee who you know his name, but I will leave it anonymous. There was a 50K in x86 assembler program. And the guy who wrote it was long gone and it had a bug in it. And they passed it to programmer after programmer, can you fix this? And nobody could fix it. And nobody could fix it because the guy used MASM, the M stands for macro, MASM, invented his own language using MASM macros and implemented his whole project in that. And the problem with inventing your own language like that is it's always kludgy, clumsy, undocumented, and nobody actually knows how it works. So he handed it to my friend who worked at Microsoft, who came back in 2 hours and had it fixed. And the other programmers had all spent weeks working on it, could not make heads or tails of it. And his supervisor asked him, well, how did you figure out that macro language? And he said he didn't. I ran it through a disassembler, which produces assemblable code, found the bug in a few minutes and fixed it and checked in the new source code, which was the macro assembler code without any macros. That's why.
But if you make your own language and document it properly,
You won't.
they do actually.
No, they don't. They never do. When
I
people
don't know if
invent
you've
their own
heard of-
language, they never document it.
Before C++ and templates, Windows wrote their own macros for singly linked list, doubly linked list, based entirely on macros. It works, it still is there. Yeah, thanks.
Okay, I'm gonna be blunt. No higher.
I was hired. They hired the people who hired those Microsoft, those Windows guys. They're still working there probably as a VP or something by now.
Well,
Yeah.
I'll tell you another
Just
story.
my opinion.
I've heard of multiple projects written in Lisp. And you can't use Lisp without using macros in Lisp because the language isn't powerful enough, but it has a powerful macro system. So what happens is whenever anybody develops a project in Lisp, they invent their own language to go along with it. And every time these projects got scrapped and rewritten from scratch because nobody could figure out the language.
If you look at some Windows kernel source code now written in C, it's full of macros.
Yeah.
Just
And one thing, I used to use a lot of very clever macros in C. I took them all out.
no, they're all very well documented. Before
Didn't matter.
these fancy C++ templates and things came along, they made their own using just packages.
This way, I got more controversial stuff coming.
That's right.
A lot of these have been debated to death. This is why D doesn't have macros, by the way. Okay, regex expressions with operator overloading. Now, there's a fellow who developed a regex in C++. Regex had been using operator overloading, and he was very proud of it. And if you looked at the code, it looked like ordinary C code, but it wasn't. It was his DSL, his own vaguely documented DSL. And he was so proud of it. I said, that's very, very nice because, he was a good guy and very proud of it. But in the back of my mind, I was thinking, when I developed D, we're not going to allow people to do that. So D has limited operator overloading specifically to prevent making a regex DSL using operator overloading. Operator overloading should be used only for having your arithmetic types. All other things like IO streams, which is a horror show. And
I wish I
C++
was over here.
have even admitted now that IO streams was a disaster. Somehow it never goes away. Like, I can never remember which way does the angle brackets go for the input and the output. Do I put it on the left side or the right side? Anyhow, metaprogramming macros, argument dependent lookup. Boy, what a horror that is. Here's my favorite. Substitution failure is not an error. How can you ever, in your right mind, write code that relies on that? Then there's, stealing from Saturday Night Live. Is it a floor wax or is it a tasty dessert topping? So, in C++, you can have an object called a class. And is it a reference type or a value type, or is it, and I see this many times, both?
A class, a variable can be a reference or a value, not a class. But
Yeah, and it can, you can have, it's like a whale with legs. You can build these things in C++ that partly work like a value type, partly work like a reference type, and you got to be really careful or it's going to do the wrong thing. So these design, you cannot have the floor wax and a dessert topping. You have to pick. And of course, multiple inheritance. Everybody hates multiple inheritance, except some crazy people. So
I don't.
I'm
being too controversial.
Mark not hired you, so.
I don't want to be hired. Never applied for a job. Thank you. I wouldn't want to code in D.
Yeah. Probably is not the right language for you,
When you say you don't have multiple inheritance, are you still allowing interface inheritance?
Interface, multiple inheritance is okay. That's
Okay.
allowed. However, we've still had trouble with multiple inheritance on it, but not as much trouble as if you have values in it. Okay, so the next thing is your code should flow like a book. You read right to left and you read top to bottom, and our code works like that. How many people's code works like that? Okay, next slide. See, this reads inside out. Which is executed first? A is executed first, and then B is executed. And which function does the three connect to? Who the hell knows? I don't know. I'd have to sit there with my pen, pounding the parentheses, and whenever I'm counting parentheses with the tip of my pen going, now, did I count 6? Was it 7? I go back and do it again. So, universal function call syntax to the rescue. So now we know that A is evaluated first, and then A is passed as an argument to B, and B is called, and then the result of that is passed as an argument to C, which is then passed to an argument to D, with an additional argument of 3, and then E, F, and G. And you see how much more comprehensible about this. This was a early D innovation, and now everybody's copying it. I think even C++ is doing that now, isn't it? Yeah. I mean, it
There have been
is.
proposals too, but they've been rejected.
Why did they reject them?
I don't remember the details.
Oh, okay. Well, this was kind of a shot in the dark to do UFCS, but it was just like a home run. It became apparent very quickly. Next slide, please. Here's a simpler example of left to right, just in case the other one was a little too bizarre. We have the old way and the new way. And here's how you do top to bottom with universal function. Universal function call syntax. So you don't need much, could you go back, please?
Sure.
You don't need much documentation to know what this does. It get SCD in, everybody knows what that is. Well, you're reading it by line, you're keeping the terminator, you're mapping it to make a copy. You're putting it in an array, then you're sorting the array, and then you're copying it to SCD up. Another interesting thing is there's no branch or loops in there. It's all just da 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 da. So it, the thing about documentation, it's always missing, incomplete, or wrong. Those are the only three states that documentation can be in. So the idea is, this presentation is not about documenting your code better. It's about writing your code so you don't need documentation. Because if your code works, your documentation is correct because your code is a documentation. Next slide, please. Okay, here's another truism. This has been known a long time. It's called cyclometric or cyclomatic complexity, I think is the right word for it. The more controls, the more confusing the code is. My favorite Mr. Spock line. Okay, does everybody remember the episode of it? See, this has never tops anyone list but me.
Is this the one where the two civilizations are fighting, controlled by the computer?
No, this is when somebody's on trial and Mr. Spock is on the witness stand.
Oh, yeah.
Shaw is the lawyer.
If you don't have conditionals or loops, how do you do iteration and?
Well, if you go back, you can see it. I use things called ranges.
I didn't see anything there with just conditional execution or anything which was iteration, that iteration. Do you have an example? Maybe I'm
Just
familiar with.
that one, yeah. I mean, normally
I
this is
don't
done
see
with
any
loops.
iteration there.
The byline is basically like,
Oh, yeah.
like an enumerated, and you pass continuous, like a map is a function you apply to everything. In the
And what
byline.
happens inside the implementation of byline? How do you do the iteration?
Okay, a byline has three functions. Empty, front, and go to the next entry. Okay, those are the
That's
only.
like an
three things you
iterator,
need
but
to
it's
iterate.
hidden behind nice
It's hidden
syntax.
behind it.
Nice syntax, that's about it, yeah.
In modern C++, you would do this with like the ranges stuff.
Yeah.
Range stuff, which
You would
is
similar to
similar
this.
range, and then you would type that to the next function.
Yeah.
Yes,
Eric Neeser
Exactly.
would disagree, but C++ ranges came from D.
Yeah. We build on the shoulder of giants.
Well, Eric Niebler's a giant too.
no, I'm just trying to understand. I
Yeah,
don't know anything about D. There has to be, if it's a complete language, it has to have iteration and conditions.
that's
So it's hidden behind
right.
syntactic sugar, in my opinion.
Yes.
Would you agree with that?
Yes, I would agree. And if you looked at the assembler output of this, you'll see.
Is that syntactic sugar or desert? Earlier slide had something about desert and something.
Oh, the floor wax or dessert topping,
Wax
oh,
or
that's a
dessert.
separate thing.
Sugar, desert.
That's it, a cat or is it a dog, or is it anyhow, the great thing about this was, could you go back one, please? Is when Mr. Spock is questioned like that, he says, this throwaway line with perfect assurance, I know all about them. Like there's no possibility of arguing that. It's just his best line. Anyhow, let's go on. Okay, has anybody seen code that looks like, the red stuff? The rest of the slides, the red stuff's the bad stuff.
The red stuff looks more understandable to me because it says if the.
You know, I'm glad you came. I need a foil.
I'm there. You want objections? I'll raise as many.
Absolutely, you know.
Are you sure you didn't hire him before this?
I'm just, actually, he's paid me to ask these questions.
I did, yeah. It works better if you write it on the right side. Because I see the left side all the time. In my own code, I see it. And I'm looking, what are these conditionals? What do they work? It's so much easier to understand if I do Y, I do Z.
You do Z, but then the left side says if Z, do Z. The right side says just do Z. And the if is hidden away inside the do Z.
It is a doozy, by the way.
Just do Z. It's-
I couldn't.
I think I'll stop.
I've done this to some of my code and it's just remarkable how suddenly the code becomes clear. Instead of this mass of, loops and ifs and stuff like that, you have, oh, well, my compiler, it needs to lex, it needs to parse, it needs to do semantic analysis, it needs to do, optimization and code generation. And if you write it like that, it's like, oh my God, I understand how this works.
Yep. Hey, just notice we got a hand up, Robin.
It is not clear for me from this side how the if condition is handled on the right, in the green code. Is it hidden, is it hidden inside of do Z?
That's right. You move it inside a doozy.
Okay, thanks.
It's also really helpful if you have, optional features. You can just list the optional features. Inside the implementation, you decide, oh, he didn't sign up for this one and exit. So, okay, next slide, please. Okay, negation, my favorite bugaboo. There we go. Okay, English is a lovely language with negatives. Nobody helps nobody but himself. And of course, Mr. Spock, who does not understand English, says, sir, you are employing a double negative. Now, there's an important point here. In English, a double negative, the point of it is not to negate the negation, it's to emphasize the negation. Okay, and this is how our brains work. And that doesn't work with programming. Next slide, please. Okay, so we wind up with these things in code. If not, no way. And that is cognitively perceived as if no way. How many people have had bugs because of that?
I perceive it as if way. The negation and the no go away, and you just left with if way.
Human factors
I'm not
studies,
human.
there's
I
actually,
must be Spock.
you must be related to Mr. Spock. Okay,
I'll add, even if you do get it right, there's an extra cognitive load in there
there is,
involved.
that little knot people just don't see.
Mhm.
And a person very well respected, you all know who he is, told me, this is absurd, you're making this stuff up. I said, no, I'm not. I know I'm right. And about a year later, I ran across a paper which somebody actually studied this and found that I was right. So I sent him the paper. And being the gentleman he is, he said, you were right, I was wrong. So
You are not wrong.
I was not no how, no way was I wrong. Okay, and it's amazing the number of bugs that come about because of this. So, next slide, please. This is how you want to write your code. You want to go remove all those knots, remove all the negations, all the no's, and rethink and reframe it so you're always writing in positive things. Next slide, please. and negation inversion. Has anybody seen, hash if not Windows? How many times have you gotten that wrong? So I decided, and this is a very controversial decision indeed, it comes up repeatedly. Why do version statements not allow algebra? The only thing it can test for is Windows. Is it Windows? You cannot test for, is it not Windows? Is it Windows and not Unix? And all these other
Because
complications.
then somebody's gonna want to put in, is it greater than Windows? Is it less than Windows?
Well,
Now, are you, what,
I can understand.
Is it
that.
Linux and Windows?
what language are you talking? In C?
This is D, in C you would use hash if.
Yeah.
Yeah.
So that
Yeah,
allows
algebra.
conditionals and all kinds of comparisons.
Yes, they do
You-
have that.
They do have that.
Yes,
So what, which one doesn't have it?
D doesn't have it.
Oh.
D doesn't allow it, and people coming from C++ goes, please, I got a version algebra.
Can you do or?
What?
Is or allowed?
Nothing.
Nothing,
So
you know,
you only write
we
code
are
for-
samurai,
Yeah,
you
we
only
can stand pain.
You only write code for one platform, then not multi-platform, something which can be compiled for multiple.
Just wait, I will respond to that one.
Too.
Positive or self-evident. Version Windows, there's your code for Windows. Version for OS X, there's your code for OS X. Else static assert unsupported. Now, here's what happens when somebody ports to a new platform. And I've seen this every time in C. They sort of sneak it in as with not Windows, and they start putting their other platform code, or it's not Ubuntu code in there. And it starts turning into an unholy tangle. And people reading it lose track of which code is for which operating system. So I advocate this approach, and the language encourages this approach. And people go, well, what if some of the code is identical or almost the same, and I just want to tweak one line in it? And I go, copy the code and paste it and change the one line. And the reason for that is,
And you think that's maintainable?
yes, it's more
If
maintainable.
somebody fixes a bug in one copy and they forget to update the other copy, that's looks like a mess to me.
No.
That's my opinion, sorry.
Fixing it, making one line change for a different operating system in the middle of it, what inevitably happens is the end result gets mixed up about which code is functioning for which operating system. I've seen this happen again and again and again. And you may think that you've adjusted all your code to support the new operating system, but you're actually using a default somewhere for the wrong operating system, and you will never know, except there will be a mismatch between your code and the operating system, especially if you have a bunch of predefined numbers that are different on the different systems, and your code will mysteriously fail. So that's why we put the else clauses unsupported. So if you're porting to the new operating system, you get these unsupported assert failures, and you know exactly where you've got to go and tweak your code. And when you get no more of those asserts, then you know you've got complete support for your new system in there, or your new whatever in there.
So I think the interesting unspoken part about this is that this pattern will encourage people to minimize the amount of code that they put in these version blocks, right? So like if there is common code for, everything that's not Windows, write that as a function. And now you have less code that's in the version block, right? That you have to make sure stays up to date based on your things.
Because that's the opposite of what he's saying. He's encouraging cut and paste.
Well, no, what happens is that's the alternative. So like if you cut and paste, well, like, I don't want to do that. That's dumb. So then that's going to encourage you to put the least amount of code in these things, right? And to generalize your logic, and instead have this dictate the differences, to smooth out the differences in the platform, the API, right?
You have the generic code that works for all systems, and then you use these versions whose only sole purpose is to tweak the differences.
Like, how do I open a file? What's the function to open a file? You put that code in these blocks. Everything else after that, like,
is generic.
is generic.
I would also highly recommend that you have your operating system includes and your project includes. You should minimize the number of files that do operating system includes. And minimize the code in those files, and then your code that's doing the work, the meat, should not do any operating system includes. That's how you write, or you get your portable code to work. So much, on Windows, every single file hash includes windows.h. Personally, I believe that is a mistake. Windows.h should only be for the code that absolutely has to be there for Windows or is very specific to Windows. All your generic, your engine should not include windows.h or linux.h or any of those.
And most of those say define min-win first, and then they include Windows.
Well, I know Microsoft has their own coding standards. This one's mine. Next slide, please. Okay, I do not eat my own dog food. This is all code I've written. DMD is my the decompiler I wrote, and I have things like is no throw, is no return, no access check, ignore symbol visibility, include not computed. And I literally do have a not no throw in the code.
What does DMD stand for?
Digital Mars decompiler.
Digital Mars.
Yeah, that's my, business for name for tax purposes.
I thought D was a Facebook thing developed in Facebook. Maybe it's not the same D that Alexander Stepanov. Did he work on this decompiler? That must be a different one. The guy who wrote the template meta program.
Andre.
That was Andre Alexandrescu.
Yes.
He did.
Oh, yeah, Andre Andrescu.
And it wasn't a Facebook thing, it was a Walter thing that Andre helped with.
Andre was working at Facebook while he was working
Oh.
on.
Oh, cool.
On the decompiler.
Well, I
Yeah,
did.
I tell you
Used it at
And he gave a talk right here for some C++, some do, and yeah, C++, oh, yeah. I'm sorry, Alexandrescu, what is?
Andre.
Andre
That
Alexandrescu.
template meta programming guy, the guy who can write the most obfuscated. Yeah, I find it interesting that he worked on your decompiler.
So Stepanov was the standard C++ library,
Yeah,
not D.
no, he worked on the decompiler.
Stepanov, no, he did not.
Wait a second, I'm getting confused.
Alexandrescu worked.
Alexander. Oh, okay, sorry, forgive me, I'm confused.
Okay, so, I came up with all these rules because I've, blasted my own kingdom so many times that, I'm constantly refactoring the code, trying to get rid of this garbage. So I've been there, done that. Okay, this is all the result of bitter experience, all this stuff. Okay, next slide, please. Okay, here's another one. Compound conditionals. Everybody writes that stuff, right? How many people find bugs in their compound conditionals? That's because they're incomprehensible. It turns out that when you write them as A and B and C and D, your brain goes, I know what that means, or A or B or C and D. Yeah, your brain goes, I know what that's all about. But when it says A and not B or C, everything, at least in my brain, grinds to a screeching halt, saying, when exactly is this conditional true?
Sorry, but on second thought, Alexandrescu was the guy who wrote the template meta programming book, right?
Yes,
And he
modern
worked
C++
on the
design.
Yes, nothing to do with Stepanov.
Yes.
Right, except he was a great admirer of
Alexander
Stepanov, I can tell you that.
Stepanov wrote the STL. I'm
Yes.
talking about the other,
The
more complex.
non-templated STL at the beginning, right? And then it was like, oh.
Yeah,
we need
it became standardized by Herb Sutter and co, yeah. Alexandrescu is the one who, yeah.
By the way, I scrunched this to fit on the spot. I've written far, far more complex things. And, it's just hell. A couple of years later. Okay, next slide, please. Okay, so what I do is De Morgan's theorem is your best friend. And you can use that to untangle a lot of this stuff. And of course, as Mr. Spock would say, dazzling display of logic. Another favorite line of mine. So De Morgan's theorem can help a lot, but it can't fix everything. Sometimes what I do is I'll take those conditionals out and I'll rewrite them as trivial functions with names for what they do. And then I stack them up with the and the or, and then things become much more,
So I have a question.
not allowed.
Okay.
Okay.
So in other places where C and C++ allowed some construction that can be confusing, in other places, you encoded in D's rules that we won't allow that in D.
Yes,
So why didn't you do that here?
because I didn't think it.
And do your conditionals, are they the same syntax semantics as C's?
Yeah,
That is, it stops evaluation as soon as it probably.
yeah, the short circuit, yes.
Short circuit evaluation,
Yeah.
yeah, that's the term, yeah.
You know, and I actually didn't even think of it before you mentioned it, so. I love
Just
it.
like start it with the double pipe and then like anything you put after it just orders them all, right?
You know, that is a very fascinating
It's a
idea.
prefix multi-conditional. Interesting, you mentioned the shortcut thing because the shortcut behavior for those two things are different,
In that case, why are you saying they're equal, right?
right?
Yeah.
Well, it's the usual. Shortcut thing isn't different if the first
As
condition is
soon as you
satisfied,
configure it's false, it's gonna bail, right?
or false or true, depending.
Yeah,
on-
false or true, right, yeah.
Yeah, okay.
Yeah, no, it's,
Are they different? No, it doesn't
No,
look
yeah,
like
okay,
it.
you're right.
It's probably the same.
no. I've been using De Morgan's theorem for so long. I used to always have to stop and convince myself that it really worked. I finally got to the point where, yeah, I know it works. Stop working through the logic again, you know. I don't know about you guys, but that's, you know, even De Morgan's theorem confuses me. So I was stopping. Anyhow, next slide, please. And this is a real example of what is wrong with this stuff. And it was one of the simpler examples because I wanted it to fit on a slide. But yeah, this is the kind of garbage that you will find in every system.h file, and I mean every last one of them. Nobody can resist writing this crap. Even people who tell me that they're too smart to do this stuff will write this stuff. The only way to stop it is to have the language say you can't do that.
Is there a D equivalent you're going to show us, or you just can't do this?
I already showed it to you. It's the version.
Just the version.
Yep.
And you gotta do everything with that without any other operators, just version. I see.
Yeah, that's right. And that's what we do in D. And turns out you don't actually need this stuff. Now, I had people argue with me saying, we got to have version algebra. And they used a trick in D to make it work, which is using enums instead of versions and things like that.
You need a trick to get around it.
There is a trick to get around it. Yeah.
Why not use this? Why do you need a trick? Why not use a straightforward syntax?
Because D allows you to do anything you want. However, it
You
will
can't do
punish you
this,
for it.
You need a
Okay.
trick to do such things. It looks like you're putting more burden on the programmer to
Initially-
express a simple construct like this.
Initially, yes, it is more burden to do it the D way.
And what is the positive?
The
What do you
positive
get out of it?
is it's much easier to maintain and much more likely to work. And it's understandable. That's the positive.
Well, I think your version control, you start off, you have a finite set of elements or possibilities. And someone initially writes their code and does a little algebra to just calculate it just right everywhere they need it with anonymous little expressions and it all works. And then at some later point, somebody adds one more element to the set. And now these algebra, it doesn't work anymore and it's scattered all over the place and it's hard to find. And therefore the bugs slip in.
No, I think you
And
that's in D.
Well, your solution is rather than having all these little calculations isolated in one spot, you figure out,
Yeah.
you identify these features and everyone else just references like back to that definition And now in this one space, you enumerate like, here's the entire set, and here's how I calculate what each of these are. And the hope then is that when someone adds an element to the set, they'll go through the entire process. And since everyone else is referencing that, if properly written, it's much more likely to work than if you just have these anonymous algebra expressions spread all over the
And
code.
Is
I
that,
can proudly say that after this being in use for 20 years, it's worked great to not allow the version algebra. People come in and say, I gotta have version algebra. One person put it in the system H files in D. He came up with a scheme of doing version algebra. And it worked fine for a while, and then
You
it
keep
broke.
adding elements and it breaks eventually.
It broke. And they come to me and they say, I cannot figure out why this isn't working right. And I said, it isn't working right because you're using version algebra, and I unwound all that stuff and put it in when I did it, and it's worked fine ever since. And that was the end of people trying to say they really needed version algebra. And you don't really need it.
but the uncomfortable question to ask at this point would be, is there a comparable amount of code written in D as in C or C++?
Well, I said, yes, you can, it will sometimes be more because you are not, the point is not to minimize the number of lines of code. That is a false god.
The amount of code, the number of projects using the language. And if your study is limited to a smaller set than the set of programs written in C, then not sure I see the comparison.
All right, that's fair enough. That's a fair statement. However, I have also refactored my old C code using my approach, and it got a lot better. I used to do this all the time. I've done it both ways. D is designed to make the right way to do it the easy way, and the wrong way to do it, we make it harder for them to do it. Not impossible, we just make it hard. And I find that that little bit of, nudging works.
Forgive me for saying this, but programming languages is kind of a religious topic.
Yes,
What you think is right, I may not think is right.
except this is actually not
It's literally a religious thing.
this
I
is not a
believe.
language design issue, though, actually.
Um,
This is a programming technique. You can apply this programming technique.
No, your programming technique is based on your language design. You say your
Well, actually,
language
yes,
design, your language design only supports certain programming techniques.
Yes,
So that's going to start of a whole religious war. If you go and talk with people who are used to C++, as I am.
you're right. Okay, another thing is cast hide bugs. So especially in C and C++, you cannot grep for your casts. You need an IDE to find them. So they make the code harder to read. It's hard to tell if that cast is correct. What happens when you refactor your types? What happens with casts? Casts are a sledgehammer. In D, at least, when you cast something, you have to use a keyword cast, and that makes it easily greppable. And the object in D is to fix your types and fix your logic so you don't need a cast. Because the fewer casts your code has, the better. Cast is like, my square peg doesn't fit in a round hole, so I'm gonna get a big hammer and force it in. That's what a cast is, and we don't want to write code like that. And that link there is to a pull request where I eliminated a whole bunch of casts out of the source code of DMD. So throughout this, you'll see lots of little links to pull requests. Those are pull requests which illustrate the refactoring I'm doing to conform to these principles. Generally, the refactoring is more complicated than these trivial slides are, but you sort of get the idea how these ideas work in real code. So next slide, please. Here's one. You're calling a function X, Y, Z, Z, Y. Everybody knows where that comes from. And you're looking at that and, well, you have questions. We always have questions. Does P modify what it's pointing to? Is P coming back out of it? Is it freeing P? Is it saving P somewhere like in a global? And that function interface gives you no clue, which means you need documentation to back it up. And of course, the documentation is always missing, incomplete, or wrong. Those are the only possible three states for documentation. Yes, sir.
There's a transient state. Sometimes when it's first written, it could be correct briefly.
Could, but I doubt it. Documentation I write is always wrong and I'm always fixing it. It's always wrong. Okay, so next slide, please. So D has some attributes you can use to help with this. And the attributes tell us that P doesn't modify what it points to. That P is returned. That P is not freed and a copy of P is not squirreled away. So by using these attributes, which are optional, by the way, but when you use them, the payoff is you don't need to document it because the compiler will enforce it. And in fact, one of the things people complain about with D is the compiler is really, really rigid in its enforcement. It does not let you do those things that you say you're not going to do with the attribute. And people go, well, it's actually logical const. You know what logical const is, right? That's const that's not const. Well, I won't let you do logical const because it's not const.
A quick question. Assuming you do this and, it's enforced, does that also allow the optimizer to then come in and perform more optimizations?
That is a great question. And no, it does not. It does not because there's always a dirty way around it.
Okay.
There's a thing in D called system code. And you mark it with that system in front of it, and system code will let you do whatever you damn well please. And there's also an inline assembler.
So the return scope is what indicates that P is going to be the return value.
That at least part of the return value will contain P. Like if it's a pointer to if it returns a pointer to a struct that, so let's say, contains the value P. Okay.
I see.
Okay, it doesn't have to actually be P itself. It can be part of the data structure return.
But this one is returning a const star. It's not star star. It's returning a character pointer. There's no struct there. So in this case, it has to be returning P, nothing else. There's no other possibility.
No, well.
Like if this function were to return P plus 1, would
With the return,
I'm
yes.
trying to understand what are the
return.
semantics of that return scope? What does that mean?
Scope means it doesn't escape the function. Yes, P does not escape the function.
Escape the function meaning?
Escape the function means you took P and you assigned it to a global, or you threw an exception with the value.
How about if you call, if X, Y, Z, Z, Y calls another function, passing it the value of P, is that allowed? Is that considered escaping, or I'm trying to understand what that means?
If XYZ calls another function that escapes P, that
No,
would not be allowed.
that passes it, it calls XYZ, let's say XYZZY calls a function XYZ and passes the value of P. Is that considered escaping? That was
Yes.
my question.
If the XYZ does not also annotate with scope, it will be considered as escaping
Escaping.
and it
that
will
is
get a compiler error.
error. Okay,
Yes.
fine.
So yes, we've tried to sew up all the little mouse holes and cracks where things can slip
And
out.
how far can the compiler check that?
It only has to go one level.
Why one level? Why does it support like?
It's transitive.
No. If it returns a pointer to a struct, that has a pointer to another struct, that has a pointer to another struct, can the compiler check?
Yep.
It does?
Mhm.
How can it?
It's
How
called.
can it? I don't think.
Very, very smart.
I don't think that's possible to.
It actually is.
It comes down
It's
to
actually very, very easy. to do.
computability. I doubt it
No.
is.
What it does is on a scope pointer.
I suspect you mean one level. when you say return scope,
Yeah.
it means either it returns a pointer, the exact copy of the pointer, or a pointer to something that contains it immediately, not transitively somewhere in a long chain.
What the compiler does is very simple. It just simply says, if you're assigning P to something the compiler cannot figure out,
Okay.
it says,
No. So even though it could be returning the thing, if the compiler cannot compute it, it says.
the
no,
compiler
it
takes
throws an error.
a
Fine.
very conservative approach.
Okay.
Okay, so it's actually very simple to implement.
Yes. Yeah, it's an approximate thing. The compiler cannot
Compiler
determine,
errors.
whenever it cannot determine exactly that it is so, it fails.
Right. If
Okay,
it might return it, it gives an error.
yes.
Okay, that's how it.
Only if it can prove somehow that it will return, it says, okay. Any other case is rejected. It has to be so.
Okay, memory allocation. How many people write string code in C and they have malloc somewhere in their string code to allocate a new piece of data because you can't slice strings in C without allocating data? So how many people have malloc embedded in their leaf functions?
Not anymore.
Not anymore? Oh, you're smart. You should be giving this talk. I eventually realized, and this took me a long time to figure out, that you should never allocate memory in your leaf functions. And the reason you shouldn't do that is when you return that allocated data from your function, who's responsible for it? Which function do you call to free it? And
free it.
yeah, so here's what we do is instead of allocating it ourselves, we pass in an allocator as a parameter. That way you can completely control the allocation and what happens to it. And where you're writing output, instead of writing it somewhere, God knows where, you have a sync parameter and your output goes to the sync. So next slide, please. Okay, so now this is a really compressed real piece of code. So if it failed, there's the not success. Nots are bad. Bad boy there. It calls the error function and with an error message. You know what the problem with that is? I can't unit test it.
Why not?
Well, the error went off to some function named error. That's not part of my unit test framework.
Then maybe that's an issue with your unit test framework.
Well, unit test framework should not have to deal with anything other than the function it's unit testing. But here it has to go.
It has to have a way of testing success or failure.
Exactly.
And if it cannot, if success or fail, one of the failure modes is that error expansion limit, and it's not able to catch that, then it's an issue with the unit test, is what I would think, but that's just me.
Okay. So, well, here's my solution. I pass in an error sync. Error sync is an abstract interface, which has a member called error, and I pass an extension error thing. And when I'm unit testing, what I do is I create a sync that just doesn't do anything. Because I'm testing, because I know my unit test, it's never going to fail on that. So I don't need to have this try to parse standard out to capture the error, which I've seen people do. They'll try to, capture STD out and check that the output's right. And this is a much, much easier approach. You just create an error sync and pass it to that. And you have different syncs for different purposes.
Yeah, I've noticed this pattern helps a lot with like using third-party code also, because you can, if you have your own error handling logic and you want to use someone else's library and they have a pattern like this, then you can just integrate everything.
It's very generic. And so there you have the pull request where I made this change. You can see for yourself. Next slide, please.
You could as well implement your own version of the error function in your unit test framework, and it'll do whatever your async dot thingy does.
Right, but async makes it easy to do it because then I don't have to, it's easier to do it. Okay. The original code here would read a file. And I would pass it a file name and it would read the file. And I was looking at it going, well, this is ridiculous. I don't really care about the file. All I care about the data. So I changed I refactored it. So the file was read by the caller and I just pass in a buffer with contents of the file. And all of a sudden, all the imports in that file just started disappearing because I didn't need the file import module. I didn't need all these other modules because really the function did not care about file IO. Why is it importing file IO? So I fixed it so it did not care about file IO. I just pass it in. And this makes it great for unit testing, again, because I don't have to prepare a special file for it to read. I can just pass it the text I want to pass it. Special file needed. Much easier to unit test. And there's, of course, the pull request. Next, please. Okay, remember what I said about your environment and operating system craft should be someplace else? Well, here's an example of that. Down deep in my code, I'm calling getEnv. I'm going, that's really, now I have to,
And I see you have a conditional, so your language does have conditionals.
Yes. And so what I did was I called getEnv in the caller and passed it in as a parameter. Oop, I don't need to access the operating system anymore from inside my function, and I can unit test it. And so next one, writing file, same thing. The old way would have its own buffer, and the buffer would get filled and then it would write a file. Well, I ripped out all the file IO and now I just pass it an output buffer. And it just fills the output buffer and doesn't care what the caller does with it, which again makes it easier to unit test, easier to reason about. It doesn't do any file IO. So that one worked out nicely. You'll also notice this is all the same function.
Yeah.
There were a lot of problems with this function.
So with UFCS in the mix, you would be able to do something like m.gendoc file parens outbuff, like when you
Yep.
call it.
Yep, absolutely. That's a very good observation. So next slide, please. Okay, here's another problem I had. I had a function which needed to, the only thing it needed out of Unicode is this character the start of an identifier? Unfortunately, the Unicode module was this gigantic thing, which everybody who uses Unicode knows, with all these conditionals and all this nonsense. And I was thinking, I really don't want to import all that nonsense into my code just to determine if something is the start of an identifier. And I finally realized I can use a pointer to a function. If I use a pointer to a function, I don't need to import any of that garbage. I just pass it a pointer that says, oh, this is an identifier character, that one is not. And to belabor the obvious, makes unit testing easy. Because really the function couldn't care less about Unicode. All it cares is this start of identifier or not. So poof, went away another bunch of imports and a bunch of dependencies. Next slide, please. Okay, there are two categories of functions. Functions that alter the state of the program and functions that ask questions.
That are usually called predicates. Something that returns a true or false value.
Okay, I would say that is a ask a question type.
Yeah, that's what I'm saying.
Okay,
The ask questions are usually called predicates.
now for efficiency reasons, I would normally do both in the same function. I would ask questions and have it, just tweak things around a bit. And I finally realized that was a bad idea. And I started separating things to functions that ask questions and do not change anything in there, and then functions that do things. And the neat thing about functions that just ask questions is not only can you make them const, you can often make them pure. And pure is a very difficult attribute to design your code to fit. But when you do, you have achieved enlightenment. People complain that the pure thing is too rigid. You know, like most attributes in D, it is very rigid about what it considers pure. And people complain about it. And I say, well, look at it this way. When you manage to make your function pure, you have accomplished something. You can be proud of it. It's, you know, damn it, this function is pure and the compiler says it's pure and fine.
Can interrupt for just a second. What's the difference between constant and pure?
Const means you can't change your arguments, okay? But you can still allocate memory and you can still modify other things. Pure means you can't access globals.
Yeah, so basically no side effects. Is that-
No side effects, yeah.
Yes. You mean pure does not even read globals? Is it just
It can read immutable globals,
read but not?
not modifiable globals.
Yes.
So
Oh,
if
it is-
people go,
No, you mean it can only read const globals,
and
something like that?
D has two versions of read only. One is const and the other is immutable. Const means this view cannot change it. Immutable means nobody can change it.
And it's assigned a value when
Immutable has to be assigned by the compiler or at program start.
start.
In the image.
So immutable is the compiler's way of saying, well, there's another thing that people complain about because it means it.
And what
The
is,
neat thing about immutable is in multi-threaded programming, you don't have to synchronize on immutable data.
if you're trying to analyze things, then yes, if you call something pure and it accesses mutable data, then
So, you know, if you're passing immutables to your multi-threaded code, you don't need synchronization and you know that it's gonna work. So next slide, please. Okay, this is why I don't use source code formatters, because I like to line things up because our brains are absolutely marvelous at pattern recognition. And when you line things up, anything that breaks the pattern, your mind is gonna zero in on that, like, you know, a black mark on that whiteboard there. Okay, your mind just gonna zero this is, so I like to line things up, makes things much more readable. I can't tell you how many bugs I found by taking a code run through formatter and then lining things up and go, oh, there's a typo here. Next slide, please.
Actually, can I ask a question about the previous slide?
No. Oh, what the heck? Go back.
oh, no questions.
Okay.
What do you think about aligning colons and semicolons?
Sometimes I do it, sometimes I don't. I haven't really reached a decision yet, unlike Professor Marvel. So I guess they probably should be lined up, but I didn't in this slide.
Why, for example, I line those things up is because, for example, if I initialize multiple fields of a struct or a class, and sometimes I just do a vertical selection and copy a set of fields into a place where they need to be initialized, and they automatically get aligned, even assignment signs and semicolons and things like that. That simplifies vertical block copy and pasting. That's why I was just curious. What do you think?
Okay.
But that's okay.
Yeah,
No worries.
I didn't use an IDE to develop this, so yeah, that's a nice feature of your IDE.
Quick note, 20 minutes left.
20 minutes left? Okay.
Oh, okay.
Next slide, please. Okay, there are two kinds of pointers in D. There's a star and a ref. The difference between them essentially is you cannot do pointer arithmetic with a ref, which turns out to be really nice because when you're passing a pointer into the function, you know that nobody's going to do pointer arithmetic on it. So,
It kind of analogous to C++ references and
yes,
pointers.
it's very analogous to C++. Okay, so some takeaways. You'll use the language features as intended. If you're trying to do the backdoor stuff, you should think twice about it. Often the backdoor stuff is nice if you're like trying to solve a bug or a problem and you just need to do something dirty to track down the problem, like putting a printf in your pure statement. The printout, that's okay. If you have to do it, but try to use the language features as they're supposed to be used, avoiding negation, left to right, top to bottom. Functions should do everything through the front door, which means no side loading and of your code. Don't mix up your program's engine with the environment. In other words, your windows.h should only be in files that need it. Reduce the
I have a question. Do functions do everything through front door? Does that imply anything about dynamically loaded libraries or something like that?
no.
It does not.
No, it's just about functions. And it's just, you shouldn't have hidden parameters to your
Okay.
function, like globals. Another thing I found is, keep trying. This is a process. It's kind of the journey. You'll never really get to perfection on this, but, we can always try. And keep trying. It's worthwhile. So, and I do this constantly when I'm kind of don't really want to tackle something new or something complicated. I'll just pick a random file in the database, look at it, and I always find stuff that I can improve. So it's a constant process. Oh, next slide, please. And this has nothing to do with my presentation. I took up dirt bike riding at my advanced stage, so.
So you're the sole person in charge of the language. You decide what happens, what changes to make, what goes, what.
Well,
Is that a committee?
theoretically I do, but in reality, it's kind of a community consensus.
Okay. It's not like the ISO C++, Sutter and Go.
Well, we don't really do things by a vote. It's just more like we argue
like
tooth
it,
and nail
so-
and eventually, circle around and we find a solution that most people will agree with.
Got a couple of questions. So, did you like carry the second bike over your head while you were riding around the other bike or what?
Yes. Oh, who do you think?
No, that's backup. In case one fails.
I'm not dumb enough to go beginner dirt bike
Maybe
riding,
like-
biking alone.
Stand on both of them and like,
You'll notice that I have every piece of armor available.
So on the previous slide,
Okay,
I have a
back up.
question, not I have a comment about this slide, but then also the slides with the switch statement. So like, yeah, either one first, that doesn't matter. So this one, like, you had a lot of references about D and why you made decisions about D and how D is different than C and how it can kind of like, it's intending to drive the user towards these types of things. right?
Yes,
But it's worth saying that like, these things are generally applicable, right?
yes,
When we write C and C++ code, these are generally things we should be doing there too,
yes.
right? Like, don't abuse the fact that you can do weird crap with C and like give a
There
format.
are guys who write books about who
They
that's
do like a
not
format
something.
string,
What's-
hack, like, don't do that.
This applies to every language. on the
Right.
planet.
Yeah.
Right. And so, I think that's a good point to make. And if you go back to the switch statement slide.
That could be-
You go back to the switch statement slide. I'm just curious, I wanted to get your thought because it's something that has been in discussion in the C++ standards committee, for a long time. So like, why did?
You're part of the committee?
I have been, yeah. Why is D kept the break statements here? Why does it allow fall through on these? Like, or why did it not change this? And be like, oh, you have to be more explicit to fall through. The default is not fall.
Okay, it will not fall through. If you write code that falls through, you'll get a compiler error.
Okay.
However, there is a way to make it happen. It's called go-to case.
Yeah.
If you go to case, it goes to the next one. And then what you're doing is making it clear that you meant to fall through to the next case, and there's go to default in
Okay.
there too. So,
Yeah, different solutions like that were discussed.
well, we found the go-to case and the go-to default, it just It just works.
Go to case sounds kind of fragile because somebody puts a new case in there and your go-to case messes up. It's not, doesn't sound very
If you
reliable.
put the- Well, if you put another case in the middle of another case, it's gonna give you an error because it's gonna fall through.
No,
that
the fall, you should, fall through shouldn't be allowed is what I'm saying.
It isn't allowed. You actually have to say you want it.
Say you go to case, but then if you say go to case, what if some new thing is added in the middle? That
Doesn't
go to
matter.
case sounds fragile to me is what I started off.
No, it won't be fragile, because if you just add a case in the middle, then it would fall through to that case and give you an error.
Because you have to explicitly list the case you're going
The
to.
control flow gets complicated. I believe you had a slide about cyclomatic complexity. If you have a bunch of go-to cases there, it's good
Well,
jumping.
Why don't we go to the board then?
Oh, no.
There is one thing good, better about this go-to than the normal go-to, which is that generally the scope of where you could go to is smaller,
Yeah,
right?
that's
It's like
true.
jumping
But go to in any,
weird places.
in any situation,
Yeah.
but that's just my opinion.
Okay? Now, if we had another case here, you're gonna get an error right there. Because you didn't insert a go-to case button.
And if
I'm sorry, if you add, what'll happen if you add, if you do what, will you get an error?
Okay, you start out with this, right?
Okay.
And you add another case.
Uh-huh. Okay,
So let's add another case here.
uh-huh. Okay.
Now the compiler will give you an error.
Why?
Because you didn't go to case here.
it's, you have to have a break or a go-to case. Is that the right way to put it?
Yep.
I
Break,
understand
continue,
your
go to
example,
or
but
Go to case.
I will not press the point.
You will not trust it?
I will not press the point. I said I don't understand,
Okay.
but never mind.
So you will have to be positive about it. You have to end all of those with a control flow statement, all of your case.
There's nothing implicit about what's
And
happening.
you'll also notice the final in front of switch. That means, if you have a case that doesn't match any of those, it throws an exception, a fatal exception.
I've got a lot more comments and questions I can make, but I wanted other people had.
And just a note, folks, we got 10 minutes left before we have to be out of the.
Do you remember who's that Scott guy who writes the books about people?
Myers.
Scott Myers.
He has a
He's retired.
programming patterns, excellent thing. They apply, I believe, to any language.
Yeah. Well, a lot of his books is how to avoid problems. and stuff. It's a
Yeah.
gold.
Which
mine
is
of-
what
Don't
you
do
seem
this,
to be
don't do this.
going
It's the same
towards,
idea. Yeah.
avoid.
Well, I'd love to hear your other criticisms.
I mean, I haven't done a lot of criticism, but like, okay, so there's a couple more sort of points, I can make, get your opinion on. So like, one thing you didn't talk about in here, you kind of referenced it obliquely in terms of unit testing and stuff, but one of the things I've always liked as a notion in D is how it integrates the unit testing into things, right? So like, you can actually say, okay, these tests run at program startup, these tests always run.
Yep.
Right, so like, you can get really early, every time you run the program, you can get a sense of, yeah, nothing's broken before I actually get into my business logic. I actually like that. It's a little bit heavy-handed in my opinion, but like, it at least forces you to answer the question, is everything working okay?
Yeah, you run your engine check before you start the engines.
Right.
I have another question, which is like a almost religious belief. What is your stand on explicitly programmer managed memory versus garbage collected memory? I am totally against garbage collection.
Okay, well, D
What
offers
is
you
your-
choices.
I just,
In D, you can use garbage collector.
there is a garbage collector?
Yes, you can use malloc free. You can use stack allocation, or
Yeah.
you can write your own allocator. And I use
If
all
I may
of
ask,
those
why-
methods in the one program.
Why did you support garbage collection?
Because it makes certain things really, really easy.
I have a very brief,
Number one, the thing it makes really, really easy is you can do compile time function execution. Okay, it's really hard to do compile time function execution if you cannot.
what is the use of, what is the purpose of compile time function execution. Why would it?
There's a long topic, but generally allows you to do complex initialization of things. You can generate tables. Before CTFE, I actually had a separate program which would generate the table, compile time function execution. Before that, I had a separate program that would generate the tables I needed. With CTFE, I was able to throw that program away and have this generation all done at compile time and
Okay, so it
initialize it.
runs and fills up some memory with something and.
Yeah, and with the
you don't have
garbage
to.
collector.
That
it's-
avoids the runtime cost. Really a big.
But the garbage collector is enforced when you're running CTFE, which means it's real simple to allocate memory to hold your array, and then you fill the array and you write it out, and then you're done.
I don't see why you need garbage collection for CTFE, but
Because then you don't have to free it. And the
if you're doing
CTFE,
CTFE, can't you?
can't you
What is the
call
cost
them?
in freeing? What is the cost involved in freeing it?
The
Your,
cost is in CTFE only works on things that it knows at compile times, and it doesn't really know what malloc does. Okay, it doesn't allow you to manipulate pointers and do all the dirty things that malloc does in order to work. So it's really hard to create a storage allocator that will work with CTFE. The other thing CTFE is used a lot for is manipulating strings. And it's real easy to just concatenate strings and not worry about allocating data for it. You go A concatenated with B and you're done. You don't have to allocate memory and then copy A in and then copy B in into it.
I have very strong opinions about garbage collection because a lot of my programming effort, software development effort is spent on properly managing memory.
Yep.
Especially in VC++ compiler, I used to be in charge of the whole program compilation, which takes a lot of memory. So I have to explicitly manage it.
Yep.
But my opinion is garbage collection promotes programmer laziness. If your program generates garbage, it must be. I wouldn't say it.
Okay.
That's kind of harsh.
No, garbage.
There are some,
No, I've heard
there are
everything.
some scenarios, but having spent so much time on managing memory, which is a very scarce resource in certain large applications, I think garbage. Okay, I don't like garbage.
Well, you have a great point.
Yeah.
Garbage collection is just one of the many methods you can use to allocate memory in D. And I recommend using it when appropriate and not using it when it's not. For if you're writing a quick and dirty program,
Yes, quick and dirty.
who cares?
Python, just want to.
Just a garbage collector.
Fine, use
If you're
it.
writing a long-lived app, well,
If you're doing whole
Consider
program
this-
optimization or SQL Server using VC++, then garbage collection
yeah.
is not a thing to rely on.
And if you're doing CTFE, the garbage collector is just super convenient. And your executable never sees that because it's all done at compile time.
Okay.
So if you've not experienced the C++ const eval stuff,
That's similar to.
I mean, their compile time
Yeah.
evaluated,
Yes.
functions evaluate compile time.
Yeah.
And they have the same constraint, right? Like your compiler, there is no, when your compiler is parsing that and trying to make sense of it and evaluating what that function
The
call
front end
is,
does all this.
there's no opportunity, after you've parsed that, there's no opportunity for the compiler to clean up any memory that it allocated, right? So
No, as far as I remember, in VC++, it's the front end that does that. The back end never sees it. The
Oh, yeah.
code generator
No,
never sees it. No code is generated for it.
Okay.
Correct.
Hey, folks, I'm gonna interrupt here because we've got about 5 minutes left. So I'd like, any last comment or we'll kind of wrap up and we all kind of need to be out the door in about 5 minutes. So I want to give us time to actually get out the door and be courteous to our hosts.
Well, my last comment is, we had more time. This is a great discussion.
Well, we can always do another one, Walter.
I believe we could have lots of debates.
Yeah. Oh, yeah.
you can use dynamic memory allocation in a const eval function in C++, as long as you clean it up before the function's over.
Yeah, you don't need to bother with these.
Okay.
Which is that C++ 17 or 19 or 20? 20, okay, I'm not very.
By the way, I expected controversy. Follow this presentation.
If anybody ever has any
I enjoyed it.
questions, plan on being here next time too, so.
Thank you.
I used to be in the VC++ backend.
So anyhow, I guess I'm going to the Red Robin after this, if anybody wants to join and